we'll dive right into the next keynote. And we'll talk about convergence of markets, fueling innovation in automotive systems. So staying also as well around the mobility space, but going a bit beyond. Please welcome on stage Nicola Liporace, Group Vice President and Low Voltage Integrated Power Division General Manager, wow, what a title, at STMicroelectronics. Welcome.
Okay, good afternoon. So first, why I'm here? I have 25 years of experience in automotive. One of my colleagues, like this one, was challenging me, hey, you are a Matusalem. You need to open your brain, thinking about AI, thinking about robotics, etc. I was reluctant. Then what I did, I said, okay, let's do the homework and try to build my storytelling. This is what in 10 minutes I will share with you. So, convergence of market. Today, rather than convergence of market, we should talk about convergence of technology from STMicroelectronics to support and to solve the needs of this convergence. We have and have divided, let's say, the chart in two main areas. One is the mega driver, another one is the mega trend, and in between the market. Mega driver is for sure the energy and how we handle the energy, so the efficiency. Now we can even talk about geopolitics, but it's not my field. I will keep this away. I will just stay within the electronics. So energy efficiency, that will call for electrification. And for sure, it's important when we talk about AI expansion and physical AI. When we go to the mega trend within the segment, clearly we see automotive is electrification, the digitalization that can be intended in several manner. One is okay, adding MCU, processing, etc., but even digitalizing the power distribution within the car, so digitalizing the backbone of the car. This is important. And for that, you need some enabler. The enabler is a silicon. Of course, within the industry, the rising star are robotics and AI factories, where power and energy really counts is important. Then we will see why. And then physical AI enablers with embedded processing and MEMS. Oh, nice convergence, nice, but you need enablers. You need a guy like ST, where across the domain, with several product family, with several technology, with several products, we may do that. So starting from power, analog, till the MCU. Now, I try to analyze the convergence of these three segments, clearly building my story from my angle of view. So there are many angles, many perspectives of which you may look at this convergence. And rather than reading from left to right, I try to read from right to left. So I have clusterized each and every segment in three subsystems or subcluster: power flow, thermal flow, and network flow. When you talk about AI, really we are pushing everything to the limits. We are talking about gigawatt, terawatt, etc. And you need the enabler, otherwise it will be only words and dreams. Who is the enabler? Again, silicon. It's the chip. When you handle so much power, or you handle so much energy, what do? You will have an associated thermal flow. Means that you should reduce the heat generation as much as you can, and what you generate, you need to dissipate. And we come again to silicon, or to semiconductor more in general. Optimization and removing the heating, for example, with liquid cooling and blah, blah, blah. But why we do this and this? Because we want to exchange data. Because at the end of the day, we use, I don't want to say waste, you use such an amount of energy because at the end we need to move data, to elaborate data. And again, a guy like ST will enable this one with high-speed data transmission, with photonics, etc., etc. So, and this is the first. So this is the clusterization for the AI. If we go now to the robotics, more or less is the same story. Clearly, the energy we are handling is much lower, but here we do not have the grid. We have the battery. The efficiency counts because once it's better operated, you have a lot of challenges. Sorry. So again, you cannot waste any single, not watt, but milliwatt or whatever it is. This is why here, because of the peak torque, or because of the safe operation, it's important the efficiency. But even the thermal flow, because going around, I heard something about handling the power, for example, in the robotics. It's not simple because we try to compact everything. And when you compact, really, temperature will increase, and again, you need to cool down, or better, if you prevent, the less heat generated, the better is, and the less challenges you have. For example, here they are working at 48 volt, because again, this helps in the direction of less heat generation. And there is a commonality with automotive, because you know, automotive is moving into the 48 volt. Last but not least is the network flow. And again, here you need the sensor and actuation, because it's important for the robot. You can imagine you have data transmission, real time. You need speed is important, and efficiency is important. Now let's go to my baby, which is the automotive. And talking about energy efficiency, of course, we brought as an example the battery, the EV. And this is important. You can imagine as simple as user, because of the mileage, because of the performance. The thermal flow is absolutely important, because in the automotive you will have an impact on reliability, you will have an impact on power density, because again, you want to pack as much as you can. When we go to the network, here is the network flow. It's quite simple, but it's really important, because in automotive you need too much to do. If you want to simplify the concept, you need basically to sense, you need to make a decision, and you need an actuation. But you need to do in a very safe way, because you know, EV is not like a mobile phone with 4 wheels. This is, unfortunately, we have experienced in some region. Now, after this story, what is my takeaway in terms of how do I see the automotive? The automotive I see is driven by, let's say, 2 forces. One is the electrification, another is the AI. Clearly there are similarities, but there are specificities that can apply only automotive. So reliability, mission profile, whatever you mentioned, is very specific. So what is important is, as for ST, we play in all the grounds, we have experience, and we can, let's say, expedite the learning curve, because we cross-fertilize the segment. We say power efficiency from conversion to digital power distribution, data creation, because we have sensing and imaging, and real-time control with the MCU. And okay, what I have reported here is we enable the vehicle to evolve from an electrical system into an energy-efficient, intelligent, and data-driven system from SDV to ADV. My last chart will be why we are here, because convergence is unrelated to here, but why we are here. Because we want to work with startup. Because we need startup. We are a giant, but we need startup. Why we need? Simple. Speed and agility. For sure, a startup will be more agile than a large organization. I'm not inventing nothing. Or we need innovation or expertise in some specific area where it's difficult to find internal, so we need to acquire from external. Collaboration to explore new field, because market is very dynamic. We will not have the speed to explore everything. And we don't want to miss anything. So this is why the cooperation is important. And then, for example, new business model a bit far away from us, like subscription service for the car, etc., etc. So this is how personal and how we see the convergence in those three domains. That's it. Thank you.